gives creativity. Creativity leads to thinking. Thinking leads to knowledge. Knowledge makes you great. As stated by Dr. APJ Abdul Kalam sir, I welcome you all for this 5 days FDP program organized by Department of Computer Science and Engineering in association with Hackathon Club.
Without prayer is a day without blessing, and a life without prayer is a life without power. Now I request everyone to raise for the prayer song. Just as the lamp enlightens the surroundings, may wisdom and awareness shine upon us. With the lightning of this lamp, may darkness be replaced by light, ignorance by knowledge, and sorrows by happiness. Like the lamp spreads light, let us spread love and for inaugurating this ceremony with the lighting of the lamp. Your presence has added immense value to this occasion. May the light of knowledge continue to shine brightly in our hearts and minds.
The greatest leader is not necessarily the one does the great things. She is the one gets the people to do the great things. Now I kindly request our respected head of the department, Dr. S. Durga Devi ma'am, to give the welcome address. Please ma'am.
Greetings and a warm good morning to one and all present here. I am extremely privileged to have this opportunity to address you all at this important moment. With the blessings of our beloved Founder President, Chairman, Colonel Professor, Vel Sri Dr. Rangarajan, our Founders President, Dr. Shakuntala Rangarajan, the Chairperson and Managing Trustee, Mrs. Rangarajan Mahalakshmi Kishore, and we are really honored to have our respectable Principal, Dr. E. Kamalnaban Sir, respectable Dean Academics, Dr. V. R. Ravi Sir, our Resource Person, Dr. Chandrasekhar Babu Sir, heads of all department and our dedicated faculty members. We are very glad to have you all with us today, and I welcome you all on behalf of Veltech Hightech, Dr. Rangarajan, Dr. Shakuntala Engineering College, to get knowledge and skill with our 5 days of faculty development program of the title Python Programming, organized by Department of Computer Science and Engineering. Special thanks to our Principal and Dean Academics for arranging such FDP that provide an insight into the concepts of Python, which is used widely. This FDP will help our faculty members to be benefited to apply Python programming in machine learning, big data analytics, and many more. I assure that our faculty members will get more benefit and knowledge skill regarding Python programming for all 5 days of FDP. Now, I'd like to introduce our resource person, Mr. Chandrasekhar Babu, representing /Prog Technologies, brings with him a wealth of experience spanning over 28 years with a significant legacy of more than 2 decades in corporate training from 2003 to 2023. He has dedicated himself to delivering over 40,000 hours of corporate training across various domains such as programming language, Linux kernel, system administration, databases, web technologies, and software design practices. His influence extends to mentoring over 15,000 engineers from prestigious organizations like Cisco, Qualcomm, Intel, Adobe, Microsoft and others. The training programs he offers are of practical insights and proven technology methods, promising an unparalleled learning experience. Splash Prog Technologies, under Mr. Chandrasekhar leadership, specializes in online training program focused on programming, system software, software architecture, design and development. This program cater to engineers and coding enthusiasts within the open source ecosystem. Beyond training, Mr. Chandrasekhar plays a pivotal role in identifying talented individuals seeking challenging opportunities in the technology domain. He guides them on various trending technologies, addressing the industry demand for skilled resources. This summary highlights Mr. Chandrasekhar Babu's extensive expertise, commitment to education and effort to bridge the gap between skilled professionals and industry needs in the ever-evolving technology landscape. I once again welcome you, sir. Thank you, sir.
Ma'am, now I request our Honorable Principal Sir to felicitate our resource person.
Sir.
For tomorrow belongs to those who prepare for it today. Education is the most powerful weapon we can use to change the world. The person who has consumed himself to change society and light the darkness in the life of our students and faculty members, the principal of Veltech Hightech, Dr. Rangarajan, Dr. Saguntala Engineering College, Dr. E. Kamaranaban sir, is requested to come on the stage and address the gathering.
Distinguished guest, Mr. Chandrasekhar Babu, and my beloved Dean Academics, heads of the departments, especially Computer Science Head, Dr. Durga Devi, who is organizing this FDP 5 days Python programming, and the members of the faculty of CSE, IT, AIML, AIDS, in fact EC, yes, all 5 departments, faculty members are attending this FDP. So delighted to have this FDP today. We were talking about this Python programming since this institute has become autonomous. The time when we were preparing the syllabus, and I think quite 2-3 years before, from the time we are thinking about to master our students in Python programming, as well the required tools for the industry to identify and to give training for such of those languages, tools. So to master our students, before that we have to master our faculty members. Without mastering our faculty members, the knowledge will not go to the student community. So therefore, our resource person today who is here, this gentleman has come already here, visited 2 times, I think, 2 times, right? 3 times. Yeah, 3 times visited. And we had a very good sessions, theory come practical sessions for first years, quite long. It went around somewhere about 6 or something like that, 7 days spell for the students, where where it goes in the morning theory and afternoon practical classes. The feedback was wonderful actually from the students. When I asked the first year head, he collected the feedback from the first years, and he came to my office and we were discussing about it, and the students gave really fantastic feedback about Mr. Chandrasekhar Babu. And indirectly, the person today, Mr. Chandrasekhar Babu, is here, for which the effort that has come from, I think, Mr. Shaktivel of Computer Science Department, and who referred Mr. Chandrasekhar Babu to all along the way to come to our college and to associate with this institute. So behind this, the person, Mr. Shaktivel. Thanks, Shaktivel. Yeah. And therefore, in sequence with this, what to say, that interactions and discussions, I requested our Dean Academics to have a Python programming for the faculty members before commencing the classes. Before the commencement of the classes, we need to have a very good, what to say, that FDP. So that should make our faculty members, that they should feel that they are strong in Python programming. By that way, where we can do something good for the student community. So by that way, Dean Academics also has taken the efforts along with the computer science head and the members of the faculty who are organizing this, coordinating this FDP, and then successfully, they brought this FDP today that we are standing before the faculty members to have this FDP for 5 days length, So therefore, I think that this gives really, even for faculty members, we say for students that Mr. Chandrasekhar Babu, he knows the length and line, the frequency or the way, the depth, the knowledge, what to give for these faculty members. He would have come with some more essence for faculty members compared to the student community. So therefore, the next 5 days will be a fruitful days for you to take up and to grab the knowledge, theory combined practical. How much ever that you spend your time with SAR's session, and so that you will become gem of this Python programming. And don't say in between that HOD called, this man called, that man called, I have a lot of work. All these works are nothing. Only knowledge makes matter. Wherever you are in the institute, wherever you go, wherever you travel, one thing that you should always, you think that where you are learning something in a day. It's something called incremental knowledge. Go on adding something. One day you will become like a person who is here as a specialist of a Python program. Specialist of a Python programming. So likewise, people need to have some interest, enthusiasm and energy, and to learn and to see that by what way that you will become something unique and innovative in nature. So that makes something always people, they welcome you with red carpet. When there is a knowledge. Knowledge is power. That makes something to become so great. So therefore, you make use of this Python programming. Don't make yourself or put gap in between wherever saying some reasons. No. 5 days means 5 days completely you have to dedicate yourself to be available with our resource person. Otherwise, no use. I request our Dean Academics also to ensure the count. All the time they are available in the lab. Okay, no missing. And we should not track where they are missing. Okay, we should not see that, we should not track where they are in the campus. No. Okay? So wish you good luck. Thank you.
Thank you for your continuous guidance and support, sir. This has opened the door for us to succeed. Thank you, sir. Now I request our Honorable Resource Person, Mr. Chandrasekhar Babu, to take over the session. Please, sir.
Well, thank you very much for inviting me for this particular session. It's a great honor to be in front of you people, all faculties. Thank you very much. And I should also thank Mr. Shaktivel for getting me onto Veltech, and also the dean, Mr. Ravi sir, principal, everyone, for encouraging me and allowing me to share knowledge on Python. Alright, so without any further ado, we plan to start at 9 o'clock, but yeah, all of you are eagerly waiting. So we will get started on the Python coding primer. So basically, this particular 5-day agenda, though my focus will be on Python, Python is just an example, it's just a language, right? My focus will be more on making sure you teach the fundamentals the right way to students. One of the biggest challenges I've seen with a lot of pass outs from engineering and various academies is that they're able to solve all the problems. They don't know how it works. They'll give you solutions, but they don't know how the solution works. So basically, what has happened is rote learning has taken over. People have memorized sorting algorithms, memorized how linked list works, all these data structures. But if I ask you, when should you use a linked list, when should you use a vector? They don't know. This circumstance, should I use this data structure or another one? Right? They don't know that. And also in recent times, there's been a big popularity in language like Python, because we will be learning why Python is popular. We'll discuss about that. Many people know Python as a language, but what you should know as a faculty is how certain things are implemented in Python, so you can be strong on the foundations, right? You should be able to deliver the right teaching, right, for the students. So that's what our focus will be on. So I think the training agenda should have been shared with you. So let me just give you a brief up in 5 days what you'll be learning, right? By the way, I'm not a presentation person. You'll see me running through slides only for next 5 or 6 slides. After that, you'll see me opening up terminal and typing code and explaining concepts by code. I feel that's what will be more engaging, right? If I just show boring presentations, all of you look at a presentation and after 3 hours, I know, you'll feel a little sleepy. I don't want to do that. I want to keep the session more discussion oriented. So if you have any questions, doubts, feel free to ask me. So don't wait for the last moment. So I want you to be engaging, right? So I want you to ask questions. If you don't know any concept, anything which I'm telling you, any jargons, any terms which I'm using, if you find there's some gap, feel free to ask me. And no questions are stupid questions for me. Some of you might think, oh, it's a very silly question, should I ask it? Don't bother, ask, right? Just ask, no matter how simple the question is, it can be even complex. You might ask me a question where I don't have an answer also, perfectly fine. I'll tell you what, the best way to learn is by teaching. I learned it the hard way. How do I know Python here? It's not, a little bit of Python I learned out of curiosity. I keep dabbling with new languages. Every time there's a new programming language, I try to see what syntax, grammar it provides, what features it provides, and try to learn a thing or two. Once I learn a language, how do I know whether I know it well? Only when I teach it to others. The moment I expose my knowledge to somebody else, I will get a lot of questions. All kinds of questions. So like I said, I have been delivering trainings on Python since the last 12-15 years around, regularly. It only refined my thought process. So if you had started my Python training back in 2003, was the first training I delivered on Python was in 2003. That time my knowledge in Python is very minimal. I would have just told what is for loop, what is if condition, what is while loop. Right, that's it. People just learn the syntax and they go ahead. Today to go back and look at that training experience, I will not appreciate it. But over time, people ask questions. For example, one question people ask is, why is string immutable? What about this? Anyone knows an answer? Why are strings immutable in Python? Yeah, why? In language like Perl, it is not.
Because it's character.
Even in C, it is a character array, right? You can modify. Any idea why in Python you cannot modify the string once you create it? Why they designed a string like that? Where you cannot add characters, remove characters, modify it.
Security.
No. Okay, let me tell you about security. This is the most misused term. Encapsulation, they say security. Right? The moment you say security of what you're trying to think, you're trying to say security is all about, you don't want a malicious user to access your system. Python is a language. Using a language, you're going to create software. So you're the programmer. Why should the language secure itself from you? It should not, right? You should be able to use the language to build secure applications. Right? So even when you learn about object orientation, when you say encapsulation, don't use the word security. That's a wrong term.
Hiding.
Data hiding.
Data.
What is data hiding? See, I'll tell you, this is just a me too. Okay? But I'll tell you why I'm telling you this is 90% of students, not students, I mean, when I teach engineers and I teach object orientation, I say, why do you do encapsulation? They say, security. Security from a programmer. He can read your source code. He can make it private to public and recompile it. Where's the security? Right? It is about data hiding. When I say data hiding, what does it mean? We like simplicity. Imagine you have a console box with 100 buttons. Difficult topic. Okay, more realistic example. What is easier to learn? Learning how to drive a car or learning how to fly an aeroplane? You know why flying an aeroplane is difficult? Because if you go and sit you've seen an aeroplane cockpit, you see a lot of buttons, a lot of switches. You don't know which switch you should turn on first. With car, at least you have one button, ignition, steering. Controls are simple, so it's easy for us to learn. All the complexity of how the car engine works, I don't have to know. That is data hiding. Engine can change. Petrol engine can become diesel engine. Today we have EV car, but same steering. We use the same steering. The brake and accelerator in the same place. That is interface. Interface is simple. Complexity is encapsulated. Encapsulation is all about hiding complexity. Why do you hide data? To hide complexity. That's what I should give you. Coming to strings, why it is immutable? You will answer that later. I'll explain some concepts, then I will ask the question again. You will know the answer when I talk about the reason for immutability. So in summary, we'll be learning about these things. Today we'll learn about the introductory concept of Python. Today you'll not really get your hands dirty and write code. We don't have that. Tomorrow we'll have that. But I will do most of the work for you. I'll be demonstrating code, explaining concepts after some time now, when I'm explaining interesting features. So we learn about the introduction to Python as a language, as a holistic view, where to use Python, what are the advantages, what are the drawbacks, what are the limitations, right? Some people when they learn a language they say it's a silver bullet. You know what it means? For everything I use this language. There's a nice quote, I read it on the internet, it said, give a hammer to a man and every problem around him is a nail. Right? So every problem is a nail. It should be like that. There are many languages, many tools, many frameworks. It's all about, if you look at any software ecosystem, it's never built in one single tool. Little bit of C, little bit of JavaScript, little bit of Java, little bit of Python, little bit of Ruby. Yes, that's a reality. Sometimes why when Python can do something, why people use Ruby? It's just like religious philosophy, right? It's like, I like Ruby, I only do code in Ruby. You know, many companies, the reason why they chose languages for building software is more about their personal bias rather than technical bias. That's a reality. I've seen many places. When I did corporate training long time back for a company called HP, I remember an experience there. The team who was delivering training to, they were all learning Java. I was teaching core Java that time. That was back in 2007 and so that particular team was getting there were like multiple batches. So there was a contract for 6 months. I'm supposed to train almost like 700 employees there in multiple batches on Java. And why are they learning Java? Because they built an automation tool in Java. And what does the automation tool do? It does something like, there's a command line tool, the old legacy command line tool that runs on the old HDFS servers. That command line tool must be automated. That command line tool is interactive, you have to feed some input to it, capture the output from it, do some activities. And doing that in Java is extremely complicated. Extremely complicated. But when it's in the course of training, only after about 4 or 5 batches I realized that, they're using the wrong tool for the wrong job. I told that this is the kind of tool, if you're trying to do CLI automation, you should be looking into Perl, Awk, Python, Ruby, these kind of languages. So some teams heard this, they did a pilot. What they expected, they were trying to do a migration in some old HPUX based, some banking application for some bank was built on HPUX, that's trying to migrate. That's a part of automation. Instead of doing the whole activity in Java, one team was doing in Java, one more team split up. They did a pilot, they did it in Perl, they finished it record time. So these kind of things happen, and I have some interesting personal experience. I will tell you about that also a little later. The point is today we'll learn about introduction to Python. Tomorrow we'll be learning about the statements and expressions. When I say statements and expressions, let me assure you, I'm not going to bore you telling what is while loop, what is if condition, what is for loop. I'm sure all of you know it. I'm going to tell you more about what are the concepts you should know beneath it, beneath the skin. When should you use a while loop? When should you use a for loop? What a while or for loop works this way. What are the iterator helpers that you should use for different use cases? The focus will be more on that. Best practices is what I'll be telling you, right? Best practices. So I'll be focusing on those aspects, and you'll also learn more about the internals, right? When you look at Python data types, we have a spectrum of data types in Python. How they are categorized? What are the patterns which are common between them? What are the similarities? What are the differences? So you should be able to put up a mental mind map, and then it'll trick your brain. You'll say, okay, integer has this feature, float has this feature, right? Then complex number has so and so feature. So you'll know the delta between them. When I say string, all of you know the string. But you know there is also a data type called bytes and byte array. How many of you heard about it? Oh, nice. Bytes and byte array. Fantastic. 1% at least. But many of them are not aware of it. When should I use bytes object over string? What exactly is a byte array? How is it different than the array modules array? Those kind of intricate details I'll be focusing on, right? So we'll be focusing more on those aspects. Day 3 will be learning about Python data types and flow control. It's all the continuum of this. And we'll learn more about string related features. This will be more of a practical session where we'll give a lot of exercises in the lab. We'll try all this. It's like, it's like competition, coding competition. You get small snippet exercises, you'll try to solve it. And figure out a method, figure out an operator, and who's going to do it in the most Pythonic way is what the thing is, right? We'll be learning about that and learn about different collections. When I talk about collections also, the focus will be on finding out the proper use cases for them. There are a couple of collections in Python. If you look at the Python's collection library, it's very refined and very simplistic compared to language like C++, STL or Java collections framework. It's much more simplistic here. But you should know exactly when should you use a deck, when should you use an order dictionary, or should you use order dictionary today. Those things we'll talk about. Counter objects, chain maps. I'll tell you about all those different collections and the use cases for them. Focus will be on those use cases. And towards the last day, you'll learn about Python functions, you'll learn about the function prototypes, the things you should know about, and all the intricate details about function prototypes. But talk about the details, see, most of us will try to memorize it. Don't try to memorize. Learn the conceptual aspect of it. So even if you're teaching a student, you don't say, okay, memorize how this keyword arguments work, memorize default argument. No, that's rote learning. You give a problem statement, you give the Python tutorial to a student, he should be able to figure it out. Okay, that's what the industry is. In the industry, no manager will say, you're not supposed to touch the internet. Don't see any resources. Write the code from scratch. That is not productive. How are problems being solved in the industry today? Stack Overflow, ChatGPT now. Right? Basically, you have to come out with productivity as fast as possible. But you must be strong in the foundation. You should know exactly when to choose what construct. That's what the focus of this 5-day session on, split into all these topics. Alright, so I know everybody, introduction to Python, the first thing today we'll look into it. What exactly is Python? Everybody knows it's a high level language, right? It's a high level, dynamic, multi-paradigm programming language. We focus on simplicity, consistency, and succinctness. That's how I define it. That's not me. It's how most Pythonistas will define it. First of all, Python is a high-level language. Why do you say it's a high-level language? To begin with, you don't do pointer arithmetic in Python, like you do in C. when you write a Python code, a piece of Python code, that code is translated to multiple machine level instructions internally. It's very much different than C language. You look at C programming. How many of you are C programmers here? How many of you know C programming? 1, 2, 3, 4. Yeah, I think at least some extent you should be knowing, right? Academic level at least. What is the essence of C there? So when you write a C code, if you're an expert C programmer, when you're an expert C programmer, well, look at a C statement and then your mind mentally translates to machine instructions that will get executed for every statement. Only then you can say you're expert in C. So people get wrung into pointer arithmetic and all that pointer jugglery. That is not very important. When you use a pointer, how it translates into your memory, computer's memory. Where does it go, right? So that's why when you learn C programming, you're an expert programmer, you talk about text segment, data segment, RO data, heap, stack. No other language will focus on that. But in C, you get into those internals. Why? Because you're looking at the memory model of it. How your program is laid out in memory, how the CPU is going to execute. That's an essence of a low-level programming language, right? So you're trying to write a program that is closest to the computer hardware as possible. That is why you use C language for developing operating systems, device drivers, embedded software, and so on. Low-level embedded software. Python was not initially meant for that. It tries to abstract the machine intricacies, so it gives a better mental model for programming. A better mental model. So today I might be using Intel CPU, it's got a different instruction set. Tomorrow I'll switch to ARM architecture or RISC-V architecture, the instructions will vary, right? How the C compiler generates instructions for different instruction set architecture will vary, right? But if I have to write a complex application, thinking at that low levelness might not be very productive. So for example, if you're a C programmer, you will learn about how linked list is implemented, how vectors are implemented, how hash tables are implemented, how to write a sorting algorithm. When you learn Python, you don't implement sorting, searching algorithm. It's already done. People have figured out the best sorting algorithm, best way to represent data structures. You use them. That's why I told you, a C programmer who's known data structures, a lot of them who come from academics, they know about intricate details about linked lists, the queues and everything. But where to use them, they don't know. Because they spend all the time learning how it is done, but where to use it, that is the problem. But when you are a Pythonista, your focus is on application. You want to use them. Somebody is done how to sort. They give you a collection, they'll know how to sort it. I should just use a sort function or sort method on a particular object and I'll get it. Now, when do I use this? What kind of data types I should use for optimal sorting? That is what my problem statement focus on. So it lets a programmer focus more on the human side of problem statement rather than system side intricacies. That's why it's a high level language. Now, it's also dynamic. What are dynamic languages? This is a big divide in the programming language landscape. In one end, we have statically typed languages. Static languages or statically typed languages. C is an example of it. C++, Java. Java is a strongly typed static language, right? So when you say statically typed, what does it mean? Because what do you mean by statically typed language? You declare variables. You will see declarations. Int I semicolon. That I is a variable, that's a typed integer. Why do you declare it? What is the advantage? Anyone?
What data type it is?
What data type it is, that's right. And yes, what is your allocating memory, yes, optimizing. See, it's basically compile time optimization. So when you say int I, for example in C, the compiler is going to generate machine instructions for this. While doing so, it's going to allocate 4 bytes or 8 bytes depending on the machine architecture as a placeholder for storing an integer. This is called compile time optimization. So you're hinting the compiler to generate optimal code due to declaration. A dynamically typed language on the other hand, like Python, C, not C, Python, Shell and Perl and all of them, you don't have types predefined. For example, in Python you don't say int I, you say I is equal to 10. The moment you say I is equal to 10, what happens? I is a label, 10 is some data, I just label on it. The memory model for this is very different. That 10 doesn't take 4 bytes. Not really. It takes much more than that. Much more than that. Later on I can say I is equal to 5.6. I can make it a float. I can say I is equal to hello world in quotes. No harm in it. It gives you flexibility. It gives you flexibility. It gives you more freedom in deciding how you want to implement your logic. Right? But at the same time, there are some limitations. The limitations are, it is difficult to implement a true compile time efficiency. You can't implement compile time efficiency. That means in compile time you cannot say, okay, I is 10, so allocate 4 bytes for it. No. But maybe later on I can say I is equal to 5.6. Floating point will have different size. Or I is equal to hello world. The size can be different. So, dynamic languages are generally interpreted. Right? The word interpreted, you might not think in the old academic terms as line by line interpreted. It's not, cannot be. Bytecode interpreted. Bytecode interpreted. These days that's what they are. Most of the modern interpreters use a bytecode interpretation. Your code is compiled to bytecode. During compilation only syntax check is done and the syntax parse tree is generated and an optimal bytecode is generated based on that. And that bytecode is interpreted by the Python runtime. Because it is interpreted, you may not get the deterministic performance. I'm using the right words here. Deterministic performance of a compiled binary. Deterministic performance, when I say, some people may think high performance, low performance. I'm not using that high and low. You will see some examples where I'll show you that Python will surpass even a C program in performance. And you'll be stumbled. Oh, Python is faster than C. You'll be stumbled. I'll show you some examples in this code, in my computer. But determinism is not there. Normally, if you're a C programmer, you can always read a chunk of statements and say, oh, these statements will generate these opcodes, if you're a low-level C expert, and these opcodes will take this many machine clock cycles to run. That is deterministic performance. You can predetermine how many CPU cycles can be used for a chunk of code to be executed if it's written in C. That's why people prefer C in low-level programming, operating systems, sensitive device driver code paths and all that, right? So things like handling hardware interrupts. It's all time sensitive. I get a hardware interrupt, I need to process that interrupt, acknowledge it in a particular stipulated amount of time, and it will be deterministic. There cannot be much of jitters here. Whereas when you look at high-level languages which are interpreted, like Python, you might get high performance, but it's not deterministic. Sometimes it will perform very high, sometimes low, depending on what kind of runtime optimizations that can be applied. That is a benefit, when you see. That's a benefit and drawback. Benefit is, it will decide how to make better. See, it's like this. Dynamic languages have the leverage of deciding everything in runtime. It's like, I want to travel from my house to Veltech. I should know how much time it will take. So I know, if I know beforehand, okay, if I go at the speed of 30 kilometers per hour or 40 kilometers per hour from my house to this place, it will take about 40 minutes. So I can exactly leave 40 minutes before time. That is determinism. Then assuming the road is empty. The road is absolutely empty. That is determinism. The reality is not that, right? The reality is traffic is there. Sometimes the traffic is predictable, sometimes it's unpredictable. Maybe there was an accident, or there somebody is dug up the road, or a politician is going across the street. So a lot of things can happen which can lead to chaos. That is a reality with modern hardware. You look at all the modern computer hardware, it's not like simply a CPU, RAM and disk and you're not dealing with simple peripherals anymore. A typical computer, it's got so much of different peripherals connected alongside, all of them want to get their attention of the CPU. By the time the CPU is getting programs executed in memory, executing instructions in memory, suddenly the keyboard wants your attention, the mouse wants your attention, the network interrupt is wanting attention. The CPU has to be repurposed for doing things. Who knows? 2 CPUs are there today, or multiple CPUs are there. Each CPU is going to try to take over the bus, right? 2 CPUs cannot access the bus at the same time. It's not possible. So one hour they have to acquire a bus lock at the hardware, they will do a bus transaction, other CPU has to wait or read data from the cache. So there is a non-determinism in hardware itself. So having a statically typed language and statically typed program might not give you all the benefit you expected in really high-end systems. Today's computers are not PCs like you use like here. Today's computers where you're hosting websites are on the cloud, which are all running in virtual machines, which are commissioned dynamically. So there's so much of jitters there, right? You don't know where your machine is running, how your web is hosted. So you want runtime performance. What is runtime performance? I don't know what time I'll reach. I'll assume that it'll take 40 minutes to 1 hour, so I'll be careful, I'll be 1 hour early. But I'll use Google Maps. Map will tell me, okay, go and take this direction, lesser traffic. Take this direction, lesser traffic. I will make judgments. When there are multiple paths, I can choose which path to use in runtime. That runtime ergonomics is provided by high-level languages. Today we live in a world where modern languages are not 100% compile time nor 100% interpretive. It's a mixture of two. Modern language like Rust, Zig, Nim, Scala, they are ultimately generate machine language. Golang, they generate machine language. But can you call them statically typed? Difficult. They use something called type inferencing. You say I is equal to 10, you don't say int I is equal to 10. Oh, you put 10, so I will be integer. After that, you cannot store integer, you cannot store string. That will take it. The thing is, it's going to make it easier for us to write code, but it's going to use that runtime inferencing, that type inferencing mechanism. So we have all these kind of innovations. Python is a multi-paradigm language. When I say multi-paradigm, what do I mean by that? Okay, some people say Python is a scripting language. You know why they say it's a scripting language? No functions, no hash include, no public static void main. How do you start a Python program? You create a file of .py extension, print hello world, run it, it works. Just like shell script, Perl script. So it's just a scripting language. That's far from the truth. Python is a proper general purpose programming language like C++, Java, Scala. It is multi-paradigm. When I say multi-paradigm, Python does not force you to write a function. See, if at all you're going to write some 10-line code which you'll not reuse. To solve a problem at that moment you wrote code. That's a script. What are scripts? Scripts are quickly hardwired logic to solve a problem at hand at that moment. So right now, for a realistic example would be, let us say you have a huge data set, a very big log, okay? A very big log file is there. In the log file, suddenly you want to look for logs matching some criteria. Initially you use some grep command, a cd command and all that, right? But maybe it's not just matching the criteria, you want to get those lines, from those lines I want to extract some fields and I want to create a dictionary and store it in some JSON. Basic use case. This is not a reusable problem. It's a problem for now. Tomorrow it will not recur. Tomorrow you want to look something else. Maybe not that log file, you look at an XML document. So when you know that you're not focused on reusability, you don't have to worry about writing functions. What are functions? Functions are block of the code which are essentially supposed to be reusable. And modularity, right? You can get a lot of functions, put them in a module or library. That's where you have reusability and modularity. Python allows you to write code which is like write once, forget it. Tomorrow the problem will not recur. You can write a script for that. But if you really want reusability and modularity, you can get functions. You can define functions, put them in a Python module, reuse a Python module across your projects and do things. So if you want reusability, it is available. And then if you want object orientation, you go with classes. Now here's a fundamental question. When should I choose to use classes and objects in my project? Yes? Anyone? When should I create classes, instantiate objects and all that? When? What circumstance should I do? I'll give you a problem statement, okay? If I give you a problem statement, how do you decide whether should I use class for that, whether can I solve it by writing functions, or whether should I write a script?
You create an object only, at the time only access that class.
Your answer again?
First of all, creating an object.
Okay.
At that object only, I can access that variables at the same time functions in the class.
See, if you want to say create a class, right? So, you
Reusability.
say the class definition.
Reusability.
Reusability. You want to use class for reusability? Functions give you reusability. And why classes? Functions and modules emphasize reusability. Am I correct?
Inheriting some.
Inheritance, abstraction, generalization, polymorphism. Okay. Let me ask you a fundamental question. When you all learned object-oriented programming, was it easy or difficult?
Without object, more number of classes can communicate.
Without object, more number of class can be. So you can do that without classes also. Just by using functions. If a problem statement is there a specific problem statement only when you use class you can solve it? Without using class you cannot be solved? You have something like that? No. See, object-oriented programming is just a style of programming. It's a style. It's just a programming style. It's more of an architectural pattern. Whatever you can solve with classes and objects can be done without classes and objects also. In fact, you see, there are some people who are anti-OO. They say OO is bad, OO is evil. Today, these people are there on YouTube, coding YouTube, right? They say, don't use OO. OO is like, OO is for, it's over-exaggerated. You can solve it without using object, without using many things.
For forward engineering and reverse engineering, we need,
Forward and reverse engineering.
definitely we need class.
No, but then you need source code. If you have source code, that's sufficient, right?
Without object, we are not able to access the class. This is for the security.
See, what is an object? It is just a way of representing your program ingredients. You have a program, your program has statements. Your statements can be broken to logical blocks and call them functions. That's called functional breakdown or procedural breakdown. Why you do that procedural breakdown? Because this set of code which is there will be repeated everywhere. This pattern is repeating everywhere. So you want to reuse it, you will put this in a function, so you can call that function reusability. What is an object? You have some data which is shared by 4 functions. There's some data which is shared by 4 functions. One function is going to update a record, right? Update a record. Another function is going to read the record. You believe that this data is only related to 4 functions or 2 functions, you put them together in an object. And the specification for the object, you create a class. What is a class? It is merely a specification for an object. But can you not do it without objects? No, you can. Like say in C language, you create a global variable, a structure, put 2 functions, one will update the structure, another function will read the structure. True, right? You can still solve the problem. Let me tell you, some people say, oh, if your project is very big, then use object orientation. The answer is correct, semi-correct. But I'll tell you a real truth. Linux kernel that drives Linux operating system, that is in which language? 99.8% C. Very little assembly. Let me tell you, it's about, last time I checked it, there's 35 million lines of code, 34 million and all. It's growing at the rate of 1 million, 2 million every year. Every year, 1 or 2 million is growing. Right? 2017 when I checked it was 20 million lines, now it is 34 million lines, roughly 24 and a half. In the 34 million lines, almost like 30 million lines in C. Purely C. All global variables, global structures, no C++, no object orientation. But they are able to build a complex piece of software. Or if you look at all the complex software you see, right? Apache Web Server, C language. Bind DNS server, C language. Send mail, postfix, C language. MySQL database, it was C, now it is C++. Now it is C++. The very early versions, of course, MySQL was written in C. Later on, they chose C++. But I'm not sure if they use all the classes and all the abstraction, encapsulation, all those object-oriented fundamentals. They use C++ because they like the design language, design idioms of C++. That's it, right? When should you use object orientation?
When you have a real world which is object oriented, and if you want to depict that in your programming language, then we can go for classes and objects.
See, you don't have to look at the real world as object oriented at all. It actually makes it more complicated.
Event-driven programming.
Event-driven, no, that is different. That is not object oriented. That's a different programming style. I'll tell you the real truth. If you're the only person who's going to write the program from scratch, and you're the only person who's going to maintain that program for your entire life, don't use classes and objects. No benefit. You know why you need classes and objects? Delegation of concerns. What about this term? Delegation of concerns. What is delegation of concerns? Okay, let me give you a realistic example. Layman's analogy. If at all, I want to cook some new dish. I want to learn cooking. I want to cook new dish. Today it's all YouTube video. But back in the days, you used to get the cooking recipe books, right? Cooking recipe for a soup, cooking recipe for so and so. If you look at every cooking recipe, you know, what is our structure in that? Procedure. Functional breakdown. Because if you look at any cooking recipe, first you have ingredients. That is data. Whatever it is, water, vegetables, all that. Next you have procedure 1, boil water. Procedure 2, chop these vegetables. Procedure 3, stir the vegetable in the water. Step by step process. Am I right? If you know how to boil water for a soup, you know how to boil water for pasta, whatever. Same process. Right? That is procedural paradigm. Have you heard this infamous quote? Too many cooks spoil the soup. You know why? Procedural paradigm. If there are just 2 people cooking the same dish, what is the challenge? Each one should know what each other are doing. Like I should tell, hey, I added salt, don't add salt. I said, no, you go and chop vegetable, I will boil water. That is called cohesion. 2 people should know what each other are doing. Now, imagine 4 engineers are working on a common project. One will trip over each other. One person will write a function, which will take 2 arguments now. Other person will call that function in his code. Later on, this person will say 2 arguments are sufficient, 1 more argument required. What happens in this code? It breaks. That is called cohesion, tight coupling. Right? That is a problem when procedural paradigm. Now I will tell you how it is solved in procedural paradigm. How Linux kernel is solving it. How Linux kernel is procedural. You know how many developers are working on Linux kernel? Any guess? 20,000 developers working full time. Daily. Every day their job is git pull, check, do some testing, integrate their patch, their changes, do a build, check if it's working, then send the patch set to Linux Torvald or the maintenance. It's a ceremony, everyday ceremony that goes on. So 20,000 developers roughly, approximate, not an accurate number. It's like it used to be 16,000 6 years ago. It's 18,000 4 years ago, 2 3 years ago. It crossed 20,000, almost 20,000 now. So that many people are working. How are they doing it? Okay, let me tell you how cooking is working on hotels. Hotels, right? We have a master chef. Who is he? He's a micromanager. Every single chef, right? He's going to stand and say, hey, you chop this ingredient this way. You boil water, you do this, you do this. So there's somebody who took the ownership of knowing what each other are doing. He's a maintainer. He's a maintainer. We call him master chef and they pay him hefty salary because he is the one who meticulously ensures that each person, each chef, maybe there are like 20 chefs, 30 chefs, right, who are all doing all the work, larger than that in big hotels. Somebody has to govern them, supervise them, and see what every single aspect they're doing. Even software projects were done like that in the 80s. Large number of programmers work in some banking application. You know about the Y2K era, I know this. COBOL programs, all punching all the day on COBOL. They are given code to punch. The code is like pseudocode or flowcharts. Who has created the flowcharts? Some managers. Those managers work with the architect, the main architect. He is going to meticulously say, okay, this is the overall project. This part must be done with this team, this part with this team, and they have to go and check every single aspect on a daily basis. It's a complex process. See, unless you're passionate about getting a problem solved, you can have a team like that working, like Linux kernel. People who contribute Linux kernel, they're not paid salary. They're doing it out of their free time. If somebody has to spend their free time to contribute to kernel, you must be passionate about it as a hobbyist. Nobody will do that for money, right? But if you're working in an organization, in a company, you cannot expect that. Today I work in one team, in one project, tomorrow I go, another person will take my role. He has to continue where I left off. That is difficult. That is very difficult in procedural paradigm. If you use procedural style of programming, there's a challenge in it. With object orientation, we have delegation of concerns, and I will give you a real world example of delegation of concerns. It's there everywhere. I'll tell you a classic example. Let's say car manufacturers. Let's say, take a car manufacturer like say Maruti, Indian car. Do you think Maruti manufactures tires? No, right? The cars need tires, but they don't manufacture it. Do they manufacture windshield? No. Do they manufacture paints? No. 90% of whatever goes in Maruti car is not manufactured by Maruti at all. 90%.
Engine also Renault.
Yes. They'll get some paint from one manufacturer. They'll get tires from MRF, Goodyear, Apollo. They'll only give specification. I want a tire for so and so dimension, so and so specs car. The tire manufacturer knows how to do it. The car manufacturer does not have to worry. Delegation of concerns. How tire is manufactured, not my headache. I want a tire, they should power my car. I want a battery for my car, right? I mean, even your normal cars require a battery, not just the EV, lead acid battery, right? Somebody is manufacturing, maybe Amaron, Exide. They know how to manufacture battery. Maruti doesn't care. They say, I want a battery with so and so specifications. And somebody else will take over. How is he manufacturing? How is he optimizing the cost is not my headache. I get the best battery for the price. This is delegation of concerns in real world. When you have a complex project, extremely complex project, it's not just one single program. A program has got a lot of parts. There's one part of the program that has generated a user interface, where the user has to select all the options and everything. There's a middleware that has some business logic. There's a backend that has to communicate to database. There are some extra components which will take care of security, take care of logging, take care of metrics and instrumentation. All these are independent components, and you assign them in different teams. But when you ask them to create it as a class and object, whatever internal implementation is only their knowledge, only the interface is standardized. Say, to drive a car, you don't need to know how the engine works. Do we? No. You don't have to be an automobile engineer to learn how to drive a car. If that is there, I think number of cars in India will be very, very less, right? To drive a car, you just go to a car driving class. You just need to know how to maneuver the steering, know when to use the gears and when to maneuver the brakes and accelerator and clutch. That's what you know. The car technology will change. Today we are living in an era where EV cars are coming up, electrical vehicles, right? Tomorrow if I come out with the EV car, if I'm a manufacturer, come out with the EV car and say, my car, old generation steering is not required. Let's give 2 joysticks. One joystick to go front and back, one joystick to go left and right. Will you buy such a car? I don't think so. Because you'll learn driving again. Whatever knowledge you had with the car driving, it's not applicable. That is interface. When you design object-oriented code, you focus on standardizing the interface. What is standardization of interface? Somebody knows how to use this object. Create an object which has the same feel. No change. Internal implementation will change. That's encapsulation. Implementation is encapsulated. Interface is abstracted. This abstraction encapsulation. Now you know what the real pictures. So when you are teaching this to your students, I want you to put this kind of examples. Connect this to real world. Because when we tell you, when I was learning object-oriented programming, abstraction, encapsulation, polymorphism, why such complicated English words are there? I don't know. What do I do with that program? You have to connect them. You have to connect them and show why you need it. When that why is answered, everything becomes clear. Right? Now we know one should use object orientation. When you have large number of teams working together on a common project, solving a common problem, you need delegation of concerns where one team is going to change the implementation of the logic without affecting another team from using it. Right? Think of the car changing the engine design without affecting the driver. I remember when I was a small kid, right? I'm not a car driver. I'm not into driving cars or even riding bikes. But my brother is like a bike guy, bike fanatic. Those days, there are all these Suzuki Shoguns and I'm not sure if you know this generation, Suzuki Shoguns and Yamaha RX 100s, 90s, like we used to go all this racing. My brother used to use my dad's Rajdoot. No, I'm not sure. It's a very old bike. You see, it's one of the Vijay's movies recently. Okay, I'm not sure which one. It's a very old bike. That time it was a nice bike in the 80s and he used to ride that bike. In that bike, I think, most of the bikes, I think the brake and accelerator in one direction. One leg is a brake, another leg you have your gears, not accelerator, gears. Gear in one leg, brakes in the other leg. He switched to his friend's bike with some bullet swap. Every time he has to hit the gear, he'll hit the brake. Right? That is breaking the ignorance. That is breaking the ignorance. Tomorrow if I come out with a new car, where I just swap the brake and accelerator, there will be too many accidents. Such a car will not even be standardized. Government will not approve. Because standardization is very important. The interface should remain the same. The implementation can change as per your wish. We always see this. That is the core essence of object orientation. Delegation of concerns, hiding the implementation, right, while providing a standardized interface. That's what you should keep in mind. Right? That's a fundamental thing. Alright, so Python is a high-level language. I told you it's multi-paradigm. When I say multi-paradigm, Python allows you to create classes, instantiate objects. All that can be done in Python, just like you do in Java. Encapsulation, inheritance, polymorphism, all that object-oriented jargons are there in Python. It's fully buzzword compliant object-oriented language. But there are some languages which are opinionated. What is opinionated? If at all you learn Java, the only way you start a Java program is class definition. Class, hello world. Public, static, void, main, string, args. Oh my god. How many words should I put? One big line. And then to say print, I say system.out.println. Very explicit, very deep. Why all that? Because the language is extremely rigid. Even if you get into amnesia and wake up and see, you'll be able to figure out a Java program. Everything is clear. Public means what, static means what, right? So it's very explicit, very purist. It forces you to create classes, even when you don't want it. There are certain problem statements where I want to just write some 4 or 5 functions. Let's say I want to, read a CSV file and query some data from it and get some report. Why I need classes for that? I need just a function. I just need a function. The function can take an argument telling which field I want to check, what is the query criteria. That's it. Classes for that is not working. Classes for that would be an overkill. And I'm the only person maintaining it. It's a small code base. Even if 2 people maintain it, it's not a big problem. But there are some languages which forces you to one style of programming. Python is an unopinionated multi-paradigm language. It lets you write a script, lets you use functions and procedures and modules for modularity. It also lets you create classes and objects. It's all based on your use case requirements, right? The reason the language is popular, if you look at the popularity of Python, it's become very high. And the reason is simply because it is a language not meant for computer science engineers. William Russell, when he created Python, his intent was for people who use Python need not know about computer architecture. You don't have to know about computer architecture, internals and all that. You should be able to still write a program. So it's a language for everybody. It's a computer programming language for everyone. Which means that no matter what your field is, you might be a computer science engineer, you might be just a data analytics person who's not into computers, you might be a scientist, it can be anything. So your field can be anything. You want to use a computer and you want to do some automation kind of work, you should be able to do it in Python. And the language is designed to be simple. It's got a very simple learning curve for beginners, but at the same time, there's a lot of depth inside the language in terms of how it implements many things. That's what we'll be focusing on. And it's supposed to be consistent. The beauty of Python is that the language design is so consistent. In my experience, I'll tell you, if you're able to write about 1,000 lines or 2,000 lines, 1,000, 2,000 lines of Python code, not 1,000 times print hello world, print hello world, print hello world, no. 1,000 lines that focuses on some problem statement, 1,000 line code to solve it, the language will map it your way. After which, as you start typing, So, if at all I write about 1,000, 2,000 lines of Python code to solve a problem statement, the language maps to your brain so well that you will start thinking in Python all the time. Why? The language is designed to be very consistent in its syntax. In fact, the Zen idiom in Python says, special cases aren't special enough to break the rules. There are no special case scenario. So you know this is, you know what it means is, when you look at a code in Python, when you look at a line of code in Python, as long as you know the syntax grammar, the consistent grammar, without any doubt in your mind, you'll be able to predict the outcome. Predict the outcome. To give you that example, let me show you a simple analogy here. May not be full-blown program, but just to give you interesting insight. Okay, open up a black terminal. That's what this is my house. Black terminal, that's where I type code. I'm just showing you a simple analogy here. Not writing a full code, just writing some text here. I'll just call this notes, okay? Suppose if I just type in a C program, right? I'm not writing a full C program, I'm writing only a code snippet. I'll say int I is equal to 10. Int j is equal to 11. This could be favorite amongst many college professors. Okay? Now I would say j plus is equal to j plus plus I. And I'll try to print the value of I and j like this, I'm trying to avoid writing a full-blown C program, but I'm just trying to show you what it is. It's a C program, C code. And you can have any code after this, it doesn't matter. So I'm just trying to show you. What do you think is the result?
Could you increase the font size?
Oh, increase the font size, yes. Our focus is confusing, right? It's confusing, right? When you look at that statement, is it looking very obvious? All of you might be thinking, oh, what about my operator precedence rule? Plus has higher precedence, plus equal to higher precedence. Oh, post increment has got higher precedence, pre increment has got higher precedence. Yeah, remember all that. So you look at this code, it will take more time. I'll tell you how I got to know this code. When I was doing training for fresher students for a company at Cisco, one of the bright student asked this question to me during tea break. I was having tea break. He came to me. I was teaching actually Linux system programming. So during tea break, he came to me and said, "Sir, I got a question in the interview. In some other company, not this other company where he's working, another service-oriented company." And the interviewer asked me this kind of question. What's the answer? I looked at this. Let me tell you. I said I don't know the answer. I don't want to bother to know the answer. The only thing I can hard to remember is Bodmer's rule. That's it. Enough. Bracket of division, multiplication, addition, subtraction. That's enough. Beyond that, I don't want to remember. Dennis Ritchie himself says in a book called The C Programming Language. He's authored that book, right? He says, after he shows the operator precedence rules, he says, don't bother memorizing it. Just use parentheses when required. Avoid complicated expressions. Right? Avoid complicated expressions. You should know one important thing about programming. You're writing program not for yourself. You're writing a program that others should be able to read. Always. Programs are more read than written. If you become a software engineer, your students become software engineer, you also in future become software engineer. Consider yourself lucky if you're even given an opportunity to write a single line of code. Nobody. All the big companies. What are software engineers doing? What are programmers doing? They are not writing code. They are fixing code written by some other programmer 10 years ago or 20 years ago. That's what their job is, day in, day out. Every day they have an escalation, one bug fix request, right? A bug report. Let's go look at that bug report, fix that bug, and do that. Somebody's code you're reading. To maintain somebody's code, you should know how to read it, right? You should understand his code. What if you see code like this? What do you think of the programmer? Okay, sorry for the feedback. So, what if that somebody wrote this code, right? When you write code like this, you start cursing the programmer day and night. Who is that person? who wrote this code. Imagine you being in that position. Don't want to, right? So this is a kind of code that is not supported in Python. You know why? Python has no plus plus operator. That plus plus operator you talked about, that post increment, pre increment, that is not there in Python. Why it is not there in Python? Because it leads to confusing code. These are the kind of examples that you use, dear students. When you teach programming to your students should find it interesting to listen and engage. You should provoke them, not provoke them by thought. Say, wow, it's like this. Okay, what I thought was wrong. Oh, this is the correct way. So that kind of thought-provoking experience must be there. And only then they will want to sit in the class, right? Let's see how much thought-provoking you people find it. Are you finding all this concepts informative what I'm telling you so far?
Yes.
Right? Okay. All right. Now let me talk about, I just gave you an overview. So knowing a little bit of history is important. Because only when you know history, you'll be able to connect the dots. Why one person created a new language? Python was created in 1980s, late 80s. The first release happened in 1991. It's a very old language, by the way. It's almost as old as Java, because Java just got released in August 1990. Python, February 1991. C++, 1989. 88, 89, around that time. Right? So you look at the language is not very new. It's not some people think Python is a new language. No. It became popular recently. The language is quite old. Why would somebody go ahead and write a new language? Why should somebody create a new language? Already there's, at that time in 1980s there was Fortran, Pascal, Basica, there was Perl, there was PCL. So many languages existed. Why would a person like Guru go and say, I'll change the world and write a new language? Why is he doing that?
If the code simplified to use the
Everybody will think the world is broken and they want to fix it. Just like this, asking a question why somebody wants to create a new language, like asking why somebody wants to create a new political party. No different, right? The world is broken, I want to fix it. The same thought process Guru had. The language that he was working with at that time, so, oh, this feature is there, but it would be nice if this feature was not. Oh, this feature is looking confusing. Maybe this feature should not have been there. So he saw with many languages. He has got experience in written C, Basica, different languages. He would Perl extensively. And he realized the shortcomings of those languages. And his intent was to solve it his way. And he has his own thought process in thinking what makes a good program. Some of them could be biased and controversial. The first thing you will not like about Python, if you come from language like Java or C++, is indentation. Reminds you of the days of Fortran and COBOL. First thing they will say is, oh my god, this is like 1980s language, indentation rules. Every language has curly braces, beginning blocks. Why indentation? That's a bias. Because Veeravan believes in readability. Readability. There are some strictness in the language. There are certain things which are strict. What is strict in the language? You have to make sure whatever code you write should be readable by others and understandable by others. So there's some discipline is required. If you don't put the discipline, people write all kinds of code. I'll show you an example. Perl lacks that. All these are inspiration from Perl, or the shortcomings of Perl, I will say. Of languages. Some languages are extremely disciplined. Disciplined to the core. One language like that is COBOL. How many of you worked on COBOL here? Oh, COBOL programmer, fantastic. Okay, COBOL.
Identification division, data division.
Yes. So if you want to simply say hello world, you have write like about lengthy program. 70 lines?
70 to 80 lines.
70 to 80 lines to write a basic program. Identification division, environment section, data division, all those things, and A margin, B margin, all those rules. And with all that, in the procedural division where you write your code, if you put one extra space, every line after that is an error. Every line. You cannot miss a full stop. But full stop is important. Extremely strict, extremely disciplined. You know, there's an interesting thing about COBOL. You know who wrote it? Grace Hopper. You know what's Grace Hopper? She was a retired Navy Admiral at NSA. Navy Admiral in US. So she was also known to be, she's also been credited to be the first modern computer program. Digital computer, you say, right? So she was the first person to program, not even the first woman, first person.
Testing also.
Yes. She had contributed to languages like COBOL. She is also instrumental in Fortran, many languages, many names to her credit. So she actually saw that programmers lack discipline. One person write code, other person not be able to read it. Each one will follow their own style. So let us make the language discipline, like Navy and Army, right? All of them equal uniform, equal size, equal haircut, everything. I won't be able to fit into an army for my haircut, or my hairdo. But the point is, everybody has a uniformity. The language focused on that strictness. Unfortunately, Python doesn't go, not unfortunately, fortunately Python doesn't go to that extreme. It takes some things about COBOL, the indentation rules and it's working for group. You take this code, I'll copy this code, I'll show you. Okay, I'll just show you. Just copy this. Okay, it's not selected everything. Just read it and draw. Then take this part. So I put this entire camel in this, right? Now I'll save this file. And then say Perl, camel.pl. You draw 4 camels on the screen. Now, I had this experience, I'll tell you. Imagine joining a new team and the manager says, fix a bug in one of the projects. You open the project source code and you see code like this. It's always fix a bug. How much time will it take? You'll give up. Another team said, I'll join another team. I had this kind of experience back in 97, 98. I worked in an iOS company. From there, after that I went into freelance consulting in 98 and I joined a small startup. I think that's more as a consultant. My job there as working as a open source specialist there, integrating PostgreSQL database with websites that they were building. It's a small .com company. The .com boom had just started at that time. It's a very small company. It's about 15 members, that company. 15, 16 members approximately. So there's one person who's a backend developer. Only one person. Guru in Perl. People used to call him hacker. You know why? Because he runs pens in his, literally runs pens across his fingers. But when he's speaking, he'll do this, he'll do this. And he writes on something like this and he starts punching in code. Everything that you would think about hackers in movies, right? Nerds in movies, he's got all that attributes. Thick specs and writing code. And you give him a problem statement, he's there with a solution ready in no time. Very expert programmer, Perl genius. I looked at him, I thought I'll also learn Perl. I bought one book, Learning Perl, for Anders Watts. And I was learning if condition, for loop. Third day, after I bought the book, that person absconded. Those days, you get a better job. No resignation, no notice period, he just absconded. He stopped coming to the office. 3 days pass, 4 days pass, he's not coming, then we know that he's not going to come. His phone is not reachable. Right? So he got some other job. Then what happened, whatever project he was working on, that project was a really interesting one. Basically there was an XML document. I guess XML, right? You know it. So XML was the big thing those days. If you said you know XML, in 98 you're taught as, like as you know machine learning today. XML is a big jargon in 1998. XML parsers, DOM parser, SAX parser, all those things used to be there. All those jargons used to be. The point is, there was an XML document which is supposed to be output of some medical instruments. The medical instruments, right, is generate some data, maybe the patient's data in some sensor. It's called some DICOM protocol. I have a very vague idea about it. But then the DICOM protocol is in XMLized format. It gets all the details, heart rate and everything in XML attributes and element data. There's also read some important elements from that XML, create a CSV file, so that you can load that CSV in Excel spreadsheet and run some graphs and analytics, those things. The job of parsing the XML document and generating CSV, he was working on that project. And then he was building a small dashboard, with a web-based dashboard where people will upload their XML doc He'll give out a CSV file that they can copy in Excel spreadsheet and do some analytics. Everything was going good, but the small bug was there. It does not handle XML namespaces. You know XML element, right? Element tag. So you put a colon. It doesn't handle it. It is to come out some vague errors. So I'm supposed to fix that bug. Why? Why me? Because he is absconded. Everybody pointed the finger at me. This guy's got a Perl book. He knows Perl. So immediately the job was assigned to me. I took 1 day preparation. Next day, okay, they asked me, tomorrow you look at the job, right? Look at that. Take over this role. I thought it's a big role. I'll take over that. That's like, somebody is just given his big bow and arrow to somebody and taking it like a warrior, right? I took that. Next, I got preparation. Next, that day I went and read about XML parser, DOM parser, SAX parser, how XML elements look like and everything. Next day when I come back, with all that learning I had, how to open and read files in Perl, all that I learned. And when I opened this code, I was horrified. I'll show you how the code looked like. And you'll be shocked to see, it's not the exact code, by the way, it's difficult for me to replicate the exact code, but I'll show you the pattern what the code looked like. I'm going to call it horror.pl. My first coding horrors. The first line is pretty obvious, user bin, Perl, everybody knows about scripts. First line you put the script signature, and next line, you see a while, like this, and print some $5, dollar, some random number things, some dollar number, okay, which number it is I don't know, I'm just randomly putting it on here, like this it was. Some numbers like this, if, and here's where the big horror was, some cap, open parentheses and dot, plus, blah, 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 blah. It was like somebody scolding me in a comic strip, right? You see that? All the junk cat is coming up, it looked like that. So, all these A, Z. Later on, it's very late I realized that this is called regular expressions. At the time I did not know regex, and I had no idea. And this regex had all the things, back references and, look ahead and assertions and all the things in place, right? Complicated regular expressions with a lot of parentheses and so many things. And this was going for like 6 lines. 6 lines. That's it. That's all the code was. The code is only this much. Now when you look at this code, where's the XML parser? Where is he opening the file? Open, read, write, close, nothing. Right? Now Perl is got a reputation. Perl as a language. In early days, Perl stood for Practical Extraction and Reporting Language. The creator of Perl, Larry Wall, he also gave another name to it later years. He said, pathologically eclectic rubbish lister. That's also an acronym for Perl. It became a bloated language, a lot of complexities had. But the language focused on practicality, and it's also called as a do what I mean language. Not do what I say, do what I mean. Okay? I'll tell you another example of what Perl is capable of. If I just say $A is equal to 10, okay, $A is equal to 10 apples. $B is equal to 20 oranges. And so $C is equal to $A plus $B. If I print $C, what do you think is the result? This $A, $B, all variables. Okay, variables start with the $sign. Scalars with $, and arrays with that. That's Perl rule, Perl syntax. But when you look at the logic, you know that A is 10 apple, B is 20 oranges, C is equal to A plus B. If I print C, what do you think is the outcome? String concatenation. 10 apples, 20 oranges. Everyone will think that? Okay. Time for surprise. Says like this. Perl is a language with common sense. If I give you 10 apples, 20 oranges, ask how many are there total, you'll say 30. Totally 30. It says that. Apple orange one is not important. 30. That's why I'm going to tell you, do what I mean, not do what I say. I'll tell you something, but you should know what I mean. But when I tell you something.
Internal typecasting.
Yes, type coercion. Type coercion. Basically what he did was, the plus operator, right, expects both arguments to be numbers. He pass strings, as a number the string is 10, as a number that string is 20. It has a lot of things going on inside. Python is a stark opposite of it. Python is a do what I say language, not do what I mean. It's also called as what you see is what you get. If you read a Python code snippet, what you see is exactly what you get. No ambiguities. That's 100%, right? That consistency is there in the language, and that's one of the reasons why people appreciate writing code in Python, because no ambiguities. Whether I read the code or you read the code, your understanding will be same. But see, it's not like that. I think that the earlier code I showed you that J++++++, I. Based on how much knowledge you have, you may think, oh, this has higher precedence, so this will happen first, that will happen first. You know, one more thing with C language. More than 10 questions people ask in for loop. For I is equal to 0, I less enter, I plus, what happens first? Why do I care? I want to do something 10 times. What happens first, I don't care. But you should know that. To get the essence of the language. Python, you won't have the confusion, because such a for loop is not there. The for loop in Python is a very high level construct. It implements a iterator pattern, right? So you see it. Anyways, so coming back. Coming to the history, I told you that Dept created Python simply because he realized there are shortcomings in different languages. So he wanted to create a language which is not too strict, not too lenient, but strikes a middle ground. Python is strict about readability. If your code is not readable, you know what happens? Like Perl code, right? So interesting code like that. I showed you camel code. There's one more code is also there. Search on the internet, Perl DNA.pl. Search for that. You'll find a small strand of DNA. Nobody will believe it's a program. It looks like a strand of DNA. When they run it, they'll say just another Perl hacker. Where's the statement? We don't know. That is the thing. So the people will be very creative in writing code there, right? To do things which it's unthinkable. Whereas Python doesn't give you that scope. It focuses on writing code that's readable. That's one thing. So the language was designed for readability. And how did Python originate? Initially, Dept was working on a grand project by Andrew Tannenbaum, headed by Andrew Tannenbaum at CWI Labs, which is called as Amoeba Distributed Operating System Project. It's a research project to create an operating system which is distributed in nature. A single operating system that can span on a network, right? Sharing all the resources and all that. That was a research project, and Andrew Tannenbaum wrote it for his research thesis. It's funded by CWI Labs, and Dept was a developer in that project. He is also one of the developers working in that project, and he was assigned with writing a shell. At home, he was having these ideas about a programming language, so he wrote a shell for it, and that originated as Python. Why he called it Python? Python is a snake, right? It's a snake. No, it's not about the snake. Well, not in India, but if you lived in Europe in the 80s, there's one of these, during this age, right, Dept's time, when I was a kid, there's one of these television drama that used to go, television serials, right? One of these comedy skits in television used to be very popular. It's called as Monty Python's Flying Circus. Search for it on YouTube, you'll find it. It's black and white. It starts in black and white and transitions to color. We are seeing Charlie Chaplin. We know about Charlie Chaplin. It's after the Charlie Chaplin and Laurel and Hardy era. There was Here's Lucy, and then there was Monty Python's Flying Circus. So where there's a comedy character, his name is Monty Python. The character's name is Monty Python, and he doesn't speak much, but his actions speak a lot. We in Chennai, if you've been watching Tamil movies, I'm sure you can relate to Vadivelu's comedy. His actions speak hundreds of words, right? Something like that in the 70s. So it looks like Dept was inspired by that humor and wit of that character. He put that in the language. It's only later people related Python with a snake. So every project in Python is related to a snake. Anaconda, the final project. Anaconda Python, you heard about it, right? Jupyter Notebook and I was running on that. And you heard about so many things. I remember the first IDE for Python was called as Boas Constructor. Boa Constrictor became Boas Constructor. So like this we have different names related to a snake, and Python logo also. is looking like an animated snake. It's like a graphical snake form. But that's the latest story. Now if you look at some of the design ideas that Guido and Anderson borrowed, some good ideas from language like Basica, that is not being little free form, not forcing people to create classes, objects, functions and all that, comes from Basica. You ever done some programming in Basica, you say 10, REM, 20, print, start writing. You don't have to create function, right? That idiomatic programming, we derived from Basica. Even the for loop in Basica, you say for I in 1 to 10, you say that, right? It's got a similar kind of construct here. So some inspiration from Basica, some inspiration from Fortran, indentation from Fortran, right? How the block must be indented and all that. Pascal, some things borrowed from Pascal, some ideas from C. So it took a mix of languages and took all the good ideas from that, refined it, curated it and created this language. Right? Is it the best language? Definitely not. Nothing is ever the best. It's trying to be. There's no perfection, but you strive towards it, right? Always. Now you name the language Python, I told you why it was, and let me tell you, the popularity of Python in the 90s was not in the computer science community. IT industry was not using it. Banking systems are all not built in Python. The same people who worked in the Amoeba project, they were aware of Python. You know, who was the other person who was working in Amoeba project other than Guido Mandelson? Sergey Brin, co-founder of Google. When Google was formed in the next decade, Sergey Brin realized we should prototype in Python because he can think in Python. Some of the people who worked in the Amoeba project went on to join Industrial Light and Magic, ILM. Industrial Light and Magic is a popular graphics special effects company in the 80s and 90s. They're popular for the special effects for all the James Cameron's movies that time. Alien, Aliens, Terminator series, Abyss, all these, right? They're visual special effects. And the most famous one that many of you would have heard about, Titanic. All of these, the VFX was done by ILM. And you know what ILM used for gluing all the graphics frames? Python. Python is used there. Right? Python is also popular in a pharmaceutical company by name AstraZeneca. One of the earliest users of Python in the 90s. These are examples we've used. We all know AstraZeneca after their COVID vaccine. COVID, right? It's a company that was popular for building an expert system, a knowledge-based system. They had a huge data getting from various hospitals and medical resources, right? Patient data. They're able to get that information. There was a controversy around it. Somebody about the politics, sharing person details, right? All these things, sharing data, right? Privacy is not there. But they got the data and they found out what medicines had what efficacy rate on it. They created a knowledge-based system and they tried to improvise their medicines, improvise the compositions of all these pharmaceuticals, innovative research. And all that knowledge-based system that they built was majorly in Python. I was not aware of the scale of that project. I only heard AstraZeneca was using it. I know a far-off friend when I say, I'm in the Python community and I engage with all these people who are into Python world. One of them actually worked as a consultant at AstraZeneca and he showed the scale of told me the scale of the project. It's very big, fully built on Python. So we have all this in Google search engine originated in Python. Later on, all the core components they wrote in C++ and other languages, but the pilot was done in Python. YouTube is a Python company. YouTube was a startup company in 2005. The entire YouTube middleware was written in Python. Why did they choose Python? You might ask, because it's better? No, because they like the language. Because you like it, you use it. It may not be the best, but it's easier to type in Java than in Java. So people start like that. When YouTube was acquired by Google, now it became a Google company. Then YouTube became more and more popular. Then they realized that the Python runtime is a big bottleneck because everything is interpreted, right? It is slow. So a bunch of engineers in Google thought, let's rewrite the entire YouTube in another language. Then they said, no. We will have a problem with the existing developers. They will not like it. So let's do one thing. Let's make the Python runtime even more efficient. That's how a language called RPython was born. It's a Google in-house Python implementation which uses static typing for Python. which sort of deviated from Python. Python is analytical type, but Google created their own language which used declarations with Python syntax just to make YouTube faster. But then another community of folks using our Python recreated Python itself one more time, which is at least 8 times faster than official Python. It's called PyPy. Python written in Python. I'll show you that project information. The most common myth and complaints by many people about Python is that they say it is very slow, it's not fast as C or Rust or C++ and all that. But you know what? That's not the reality. This is PyPy. And you can see, they say, officially they say 4.8 times faster than official Python. They are actually very humble. They say 4.8 times. But when I do my benchmarks on my system, I am able to see at least about 6 to 8 times performance improvement in most use cases. Maybe I not used all the use cases they did. Corner case scenario, maybe it might be not that great. So I think they have been very generous about their benchmark put here. But it's a faster implementation of Python. Python has multiple implementations. PyPy is one of them. It's very popular. In the later time, I will tell you when you should use PyPy, what circumstance it is not suitable to use Python. It's not a silver bullet. You cannot just check magically and say, don't use Python, use PyPy, right? No, that won't help. Okay? So yeah, there are certain drawbacks with PyPy also, certain shortcomings, which we'll talk about later. The point is, Python has propelled in the industry, starting from non-scientific communities or not computer science communities. You look at Industrial Magic, AstraZeneca, they're not computer science, right? When I personally was delivering trainings on Python for corporates, let me tell you, from 2003 to 2010, all my Python trainings were for non-IT companies. The clients used to be companies like Yamaha Motorcycle, John Deere, Suzlon, Honeywell Automation. These are companies who are not into IT. They're another domain, right? I used to wonder why they need Python training. And last I remember I also delivered a training for IMD, Indian Meteorological Department. These are the kind of organizations that delivered Python trainings for. And who are they? Who are delivering trainings to? Scientists. Scientists, mechanical engineers, mostly scientists, research people. And I used to wonder why they're using Python. They're all using Fortran, MATLAB and all those tools, which are very expensive. Very, very expensive. Prohibitively expensive for the company. You know, products like MATLAB for the college and universities, they give them freely, lesser licensing fee. They inculcate you people to learn it. The software is good. I was having a debate with Dean also. Right? But it's fine, it's a healthy debate. The point is, yeah, that's how it is. Many commercial companies will make their products free to the company. Oracle has done that. Microsoft is doing it. Every company will do that. Why? Because that's how the product will sell. When you make sure that the infrastructure in the college learns a tool, they only know that tool and they go out in the market, they say, I only know MATLAB. MATLAB is best because they don't know anything else. But you don't know the alternative, whatever you know is best. Right? So you say MATLAB is best. Back in the days, I remember the 90s and 2000 era, Oracle database is the best. Any person will say that. Later, because he does not know anything other than Oracle. Database means Oracle. RDBMS, Oracle. You teach in Informix or DB2. Oracle is a toy database. Informix and DB2. That's enough. PostgreSQL, open source project. Far superior in features and functionality than Oracle. Far superior. It has all the features you want for database. In fact, scientific computing uses PostgreSQL, not Oracle. But why is Oracle popular? Because they make the license free in the college, they give free training, they have their own induction programs, all these things happen. They build the ecosystem. But the software is not bad, I'm telling you that, because it's got a very nice UI. Easy interface, easy to build your applications, easy to rapidly prototype and build your product. MATLAB is also the same way. I know, zero knowledge in MATLAB. What I'm telling you is based on what the Dean told me and many others are many people whom I trained on Python, they have used MATLAB. There are MATLAB gurus. But MATLAB you can just drag and drop it. Get it? Oh, Python you have to write code. But Python is free. is more flexible than what MATLAB is because you are controlling everything. You are in total control. I'm not trying to say this is good and that is bad. You should know both. You should know both. Certain circumstances, you have to build everything on your own from scratch. Certain use cases where the environment is accommodating, you can use ready-made solutions where somebody has solved the problem for you. Right? I'm not going to say Oracle database is bad. No, it's good. Because if you want to build a banking system, it's got an excellent support infrastructure. Very good, it's got very good security, very well tested and all that. It's got that market reputation. If you use PostgreSQL and say, I'll build a banking system PostgreSQL, something goes wrong, you are in fault. You are responsible for everything. Right? So that's the things you have to keep in mind. Python as a language became popular in the industry because it allowed people to provide their own alternative solutions to many commercial offerings. Testing tool chains. In early days, many people used to use Windrunner, LoadRunner, Silken Suite, many testing tool chains. Today, if you look at the testing domain, a lot of them have to know Python. They have used the suite. Even today, there are use cases. But Python has become one more tool that they will try to leverage on. So many companies use Python automation. For testing automation, use Python. Right? It's used in that cases. That's very popular in the IT industry. It's used in data analytics. In early days for data analytics, there are domain-specific tools and software. MATLAB is one of them. There are so many different commercial software available, which is optimized for data analytics and visualization and so on.
What way it differs from R language, R programming?
See, R is only for data analytics. Use R to, let's say, connect to a microservice. It's not easy. Communicating to databases, I think now there are libraries in R, earlier it was not there. In early days, R was focused on only data analytics, statistical computing. Outside the domain of statistical computing, let's say you want to connect an IoT device and pull some data from the sensors, you can't do that in R. Right? So you need a language which is more malleable. Malleable. It's like the jack of all trades. May not be the best, but jack of all trades. That means I can do this, I can do this, I can do this, I can do multiple things. So Python took that role. So I'm not going to say once you learn Python, that's end. That's not the way it is. It's a stepping stone. You learn the language, leverage all the functionalities, know the shortcomings. So you can see, oh, this is where I enjoy the benefits of MATLAB. This is where they enjoy the benefits of using R programming language or this particular tool. Right? So that's how you look at this. So you have to look at the design in this angle. You have to look at the commonalities provided by Python. Get comfortable with it. See, today I can tell you that if you want to do scientific computing, all these mathematical calculations and everything, people used to prefer R and Fortran. Later years, I remember recently there was a language called Julia. I'm not sure if you know that. It's a fantastic language, Julia. It's a very good language, right? But then Python suddenly throw one bomb like scikit-learn, SciPy. All of them became mature. So what performance you get, what are features you get with features in Julia, you get same thing the moment you start using this toolchain, the SciPy toolchain. Then why should I switch to new language? I already know Python. I know how to write a web application in Python. Now I need to do some data analytics. I want to do some statistical computing. Can also use Python. That comfort zone is provided. But then you should not live in the comfort zone because you should know what extra features these other languages provide. Use it for that. Use them for the extra benefits, right? So you should always think in terms of a polyglot. What's a polyglot? Polyglot is somebody who knows multiple languages. Like in real world, most of us, one spoken language. Your view is myopic. For example, if I only know Tamil, I don't know any other language. I only know Tamil literature. It's good, not saying that. But unless I am able to appreciate literature in other languages, it can be anything. It can be Kannada, it can be Telugu, it can be English, it can be Hindi. That appreciation will open up my mind. It will make my spectrum more wider. I'll be able to correlate many things. Right? So the whole point is, when you know one programming language, sometimes you will be only stuck in one way of thinking. The thought process will become confined. The moment you learn different languages, which will make you think differently, that's very important. The language should make you think differently, only then it's worth learning. For me, I'll tell you, it's my personal bias. When I learned Java, I tried to learn C#. I didn't find it compelling. How much I learned C#, I forgot. Why, nothing new. System.println, console.writer. Class year also. So here and there, yes, some people argue and say, oh, in C# they introduce using clause, it is not there in Java. Oh, try with resources now there. One learns from the other over time, right? The point is, you should have a compelling reason to learn a new language, because it should make you think differently. Your approach to solve a problem must be in a different direction. The moment you learn a language like Lisp. Have you heard about Lisp?
Fifth generation language. Prolog and Lisp.
Prolog. A language long forgotten. It's not a new language, let me tell you. Lisp was a very popular language in 1957. It's a very old language.
Artificial intelligence.
Those days when you say AI, it is Lisp.
Lisp only.
The first so-called AI programs, Elisa and everything was all written in Lisp. But why it is forgotten? Because Lisp is so addictive. I'll tell you why. The moment you learn Lisp to some extent, you will reject every other mindset. You know why? Lisp will map your brain very fast. Suppose you want to say A is equal to 10 plus 20, in languages they will say A is equal to 10 plus 20. In Lisp it's all function in parentheses, right? You put one function, you put set q, one more open parenthesis, then you say plus, no sorry, you say C, then you say one more parenthesis, you say plus, and then when you read it, right, it will not look obvious. But then you understand the code, you see it's a way your brain works. When you say A is equal to 10 plus 20, our brain will look at the plus symbol first. You have tailor-made our brain like that, right? Plus symbol, oh, plus is there, 10 and 20, add it. That you story?
Like a point.
Yeah. The point is it's converting from infix notation to prefix notation. So this is how it is. So with Lisp, it maps to the brain so quickly that it becomes so addictive. But it's a good language to learn. Any language that falls like Lisp, Haskell, Clojure, all of these have a similar pattern. They're all pure functional programming language. You have to learn that. Learn a language like, say, Perl or Shell or so on, because it teaches you about pragmatism. Pragmatic way to solve a problem. Right? Trying to take a completely not traveled approach to solving a problem. Perl is good at it. You look at a problem statement, line by line and say, oh, this is an algorithmic way to solve a problem. Shell and Perl will teach you pragmatic solution. I'll tell you one example for that. That's personal experience. I worked in a startup company in 99 till 2003. That's the last company. Okay, longest and the last. After that, I was a freelance consultant. After that, hopping companies, doing corporate training and consulting. In that last company which I worked, I was again there also an open source specialist. I'm good at open source. People call me jack of all trade. Any open source solution, they used to come to me. That's how it used to be. Small company again. I used to work very closely with the chief architect, by the way. So the chief architect, when he comes, what is architecture, he comes and asks, is there any open source database? Just see what can I use in database? Can I use this web application? Can I use this framework? So I had to suggest him the frameworks and all that. What framework to use? What database to use? Mostly writing software and giving talks on it. Now the thing is, there was a team of people who were solving a problem. That's an e-learning company, by the way, that time. We were tied up with a company called Addison Wesley Publication Group, which became Pearson Education in the later years. In 99 it was called Addison Wesley till 99. So we have all of their books, and all the books are available in this docbook DVD format, which are all Excel. Now that huge, like we had about 18,000 books, and each book had so many chapters. Every chapter ends with copyright Addison Wesley publication, copyright Addison Wesley publication, then XML document. There's an XML tag for that. Now, in 2001, Addison Wesley was bought over by another company called Pearson Education. A problem came on our hand. All occurrence of Addison Wesley should be changed to Pearson Education. The funny part is, I'm the only person who knows Unix and Linux. in that company. That problem statement went to a documentation team. They approached a bunch of gurus, Java gurus. The Java gurus were sitting, for 7 programmers, I remember that very well, 7 people, worked on a project spanning 3 months, writing 3,400 lines of code roughly to fix that problem. They wrote a Java code. They wrote a Java code which will use all the breadth first search, depth first search, all those algorithms, right? Traversing directory tree, opening every file you open, use a string tokenizer. Java in those days did not have regular expression. String tokenizer, tokenize a string, search for the word Addison. After Addison, if you find Wesley, then you replace that Addison Wesley to Pierce Education, the new file. All this, they're working fine. They work for some test files, it worked. When they put it on production, it used to crash with a problem, JVM out of memory. And you know why? Because there are all the Java objects they're creating, like all those things, it's a lot of memory. Java was little resource intensive those days, and yes, I should also tell you, that was a machine which had about 4 gigabytes of RAM. Let me tell you, 4 GB of RAM on a machine in 2000 era was like having 1 terabyte of RAM today. It's that kind of a scale. It's very expensive computer at that time. And they were brainstorming, saying, why Java is taking so much of memory, what do we do, this, that. They were all discussing during tea time. And I was also having tea, and also I was hearing the conversation. So they were wondering what is the problem about, and I was also listening to them. And then, that's a very close community. Right? So they were telling, they said a way to increase more memory on the server, blah, 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 blah. So what is the problem here, right? No, it's simple. We see, from 100 files we try to solve, replacing Addison Wesley to Pierce Education is working. 18,000 files is not working. Oh, you want to replace Addison Wesley to Pierce Education? Where? They show the server. Front of them, 20 seconds. All you need to do is find command, set command, a little bit of env command when the shell snippet. Ran, executed. After about 1 minute, right? It came back to the shell prompt. I said done. Okay? I looked like a hero then. After getting beaten up with that Perl, I told you, right? A Perl horror. You know what happened in the Perl horror story? When I was put in that job, I saw the 3-line code, right? I absconded from the job. I found a better job. Okay? That was like running like a coward. But then I thought I should learn Perl. I should learn Perl better. I should learn shell better. But then, so many years later, saw this. They were not able to believe. So, you are joking? We wrote 3,000 line code. We spent so many months. You wrote 4 line shells. It will work, is it?
It's a kernel program.
Then they tested it. Randomly, the calculation tested it, and everywhere it's the reality, right tool for the right job. I'm not going to say build enterprise application using shell script. Bad idea. You don't want to build enterprise application using shell script. You should use that for Java is built for building that. Right? Building enterprise application, not automation. This kind of automation is best done in shell. Now, that's why I told you, right? You have to learn different language. The problem, the advantage of shell is that pragmatism. You know this tool does this tool does this, this tool does this. The shell is a glue language. It glues all these tools using pipes and conditions and so on and makes things work. Right? And that's exactly how you solve the problem. So that's what you should know, right? Alright, so I told you how Python started its history, how it grew and what it is today, right? Now the next thing, quickly, features and benefits. I think I'll skim forward. I already told you, it's a high-level general purpose language. It's easy to learn Python programming. In fact, it's designed for beginners. In my experience, I can tell you, it is easy for me to get people started on Python programming as a first language. Case in point, recently I've been doing a lot of trainings for 8-year-old, 10-year-old kids who are just learning programming. I teach them in Python. Trust me, I just finished one of the batches recently. First batch, I did a pilot. Successful. I mean, there are 70 people who join. Out of 70 people, not all of them will have programming interest. I think 20 people survived till the last of the session. Taught them a little bit of electronics, MicroPython and all that. And they were able to write Python program to do wonderful things. I remember just yesterday, Saturday, Sunday I do that batch, right? Yesterday, a small kid, one of the kids actually showed, he said his own project. He put some 2 set of big switches. He's just finishing his 5th standard. It's in 5th standard, by the way. 2 set of big switches. One side dictionary you put 1001, another dictionary you put 0111 or whatever that. Two numbers, right? And on a OLED display, it translates a binary to decimal, does addition and shows the result. He says 9 plus 7 is equal to in the OLED display. He's able to do that. Fixed standard. Completely on his own. And that is the shocking part of it. I said, did you copy from anywhere else? No, he did all. When he showed the code, I realized, obviously, amateur coding will be there. Naming variables, that, this will be there. Obviously, he's not taken something from the internet and pasted it, and it's unique. It is something which is unique. So just giving an example, these are the kind of things people do. They get on speed. Because now he knows what a loop means, what condition means. He is able to figure out binary numbers and decimal numbers. That is a good learn. And all this through this being the first language. Imagine learning the first language as C programming. Hash include stdio.h. Why that is required? Don't know. Put it. Otherwise your code will not work. That's a simple excuse to you today. Because you have to teach why hash include is required and go to whole history. No, it's not joke that if you read that C programming language by Brian Koenig and Dennis Ritchie, that book. A very popular book, right? Written by the authors. First chapter, one full chapter, teaches you how to write Hello World program. The famous Hello World program. Right? One full chapter to teach you how to write Hello World. Right? What is it? How much time does it take to learn to write Hello World in Python? Few seconds. Print Hello World. Print is a function. Hello World is string. Like it's up to you to know what is really print. What is a function? Function is an object. Parenthesis is an operator on that function object. Whatever you put in literal is a string object that is referred to by this function. Function object, two objects are communicating. That is internals, but you don't have to know that. You can just learn with the bare essentials. So it's a very easy to learn language, right? So if you want to teach programming for absolutely new audience who has no knowledge of programming, Python is a good candidate. In the early days, I remember people used to be Basica. Basica also is not bad, but Python is also an equally good candidate for first-time programmers. And the language is designed to be easier to read. You look at the syntax grammar in Python, you'll see some words like is not, in, not in. You can write a Python statement that looks like, if user not in authenticated, print failure. Is that English? User would be a variable, not in, authenticated would be a list or any collection. The user is not in the collection, print failure. So it's very readable. So it tries to be more readable by using the right keywords and idioms. It's very idiomatic in that sense. Not too many special characters in Python. Opening, closing, curly brace, you see that in blocks, you don't have that. And secondly, it's become the de facto high-level language of choice for developing complex applications that involve data analytics. So when you're in the data analytics domain, you write really scripts, not full-blown programs. Look at how you use pandas. Many of you would have already, right? What do you do there? Write in Jupyter Notebook, you write a small snippet. Df dot blah 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 blah, you put that. What's that? It's a script. Not reusable. You want to run one analytics at a time and show some visualization or do something or skim some data. Right? So there, you're writing small code snippets in cells. Scripting like approach. Python is very suitable for that kind of use case. There are other languages which are now following that suit. Julia is also supporting the same snippet model. Rust is also supporting it. So every language is learning from the Python's ideology and one language borrows from the other. That's happening, right? So you can also use to develop programs that run on large supercomputers to embedded microcontrollers. Python, as I told you, runs on really large supercomputers also now, where a lot of data computation everything was happening. It's not the only language, it works like a glue language there. A lot of low-level performance critical components could be written in C++ or any domain-specific language, but Python is one of the things that orchestrates it. In YouTube, it's like that today. If you look at YouTube data centers, even today they use Python. They produce some optimized runtimes, some components for rendering and everything they could do. They could do it in Golang and other languages, but the glue layer, that one that connects everything together, is still in Python because it's easy to maintain. And it runs on microcontrollers. There was a time when you want to do microcontroller programming, you have to know assembly language or C, right? Even when you use Arduino, which is very popular today, the IoT device, what do you write your program on? Sketch, right? Which is C++. It's a dialect of C++. So it's a C++ syntax with on built-in libraries. But today, we have a big competitive product, MicroPython. MicroPython is a very, very popular implementation of Python that is designed to run on extremely low footprint microcontrollers. Not run on Arduino, but it works on slightly better versions like the popular Raspberry Pi Pico, or if you use the ESP series microcontroller. I have one of them here. I always carry them in my bag. I could get a working version of it, but just a minute. Today you can run Python on a device as small as this. This is an ESP01. Cost about 105 rupees to 170 rupees based on slight variations of the model, but this is an IoT device. It runs on ESP8266 microcontroller with few pins here. There are also full-blown version of ESP32 and ESP8266 boards, which will cost maybe about 300 to 600 rupees or even 1000 rupees, but the cheapest you get. A very small device. And this has a lot of shields. This is a relay module. Actually, I can have this MicroPython installed in this. I hope I can show you maybe the after. Okay. I can put this in the shield. Once I write the code, I can put this in the shield. And through Wi-Fi, I can control this relay module. Through Wi-Fi. Right? Or you can also connect it to sensor devices, like a very silly sensor I have is a DH11 sensor. It's a temperature humidity sensor, very basic one. You can also connect to this, so you can actually make it a simple weather station. So it will print what is the temperature or humidity in your room, relate your Wi-Fi, and you can get that data on your computer. If you have more full-blown ESP8266, which have more GPIO pins, you can also connect your own OLED display or LED display and so on, and you can display right there. So it means that you can run Python on even these small, low-footprint devices today. So which means the future of embedded development is not 100% C, it's a mixture. Still performance critical code you write in C. Performance critical code you write in C or assembly. But most of these high level code, which it was connecting to Wi-Fi, using communication protocols to different messages, printing a web-based dashboard, all this can be better done in Python because it saves a lot of time. Right? That's what you should do. So MicroPython is something to look into. So if you're trying to tell your students to do projects and things like that, these are some of the options or avenues you can suggest them to do. Right? Okay. Anyways, right, we ran out of time, so I think we'll break for lunch now. I think we'll continue after lunch. We just started with the basics. We are only getting started, right? Post lunch, we will get little demonstrations. I'll show some interesting programs. The good practices when you start with basic programs in Python, with choice of IDs and so on. We'll talk about the environment. Yeah.